Wow. Okay.
I don't know.
Okay, so at time t is equal to 0, time hasn't started yet, or motion has not started yet. So t is equal to 0, and v will be 0. 1 second. We are looking at the body at the time changing. Oh, somebody is complaining of not being able to join. Let me forward the link so we can continue, okay? Okay, so at 1 second, the speed is 5 meters per second. Another 1 second, we have 10. 3 seconds, I think you can guess the next speed value or velocity value. That is
Yes.
what?
50.
15. At 4, we have 20. 5, we have 25. So what is happening is that the body is moving with same speed or uniform speed within equal time interval. So from 0 to 1 to 2 to 3, 4, 5, 6. Then time we have from 1 to 5. 1, 2, 3, 4, 5. Okay, so let's plot. 0, at time of 0, velocity 0. At time of 1 second, velocity, oh, we have in 5 intervals. Okay, so we must change it to 5, 10, 15, 20, 25. So 0, 0. 1 would go with 5, 2, 10. 3, 15. 4, 20. 5, 25. And when we join the point, we also have a straight line. Now, house, Nora. Nora.
Yes, please.
Your graph or your slope is 1. Help us determine the slope of 1. Benedict, are you there? Benedict. Lawrence. Okay. Lawrence is here. Gerard, yours is 2. Gerard, yours is to help us find the second slope. Ken.
Sir.
Yours is 3. and we a shared responsibility. And if
Yes, sir.
yours is this bigger one. This bigger one. So Nora 1. I've forgotten whoever I gave the second one. Ken, yours is 3.
3.
And if yours is 4. Start with. Nora, what's your answer for the first slope?
Sir, please 5.
You had 5. So slope
Yes.
1. So change in vertical against change in horizontal. So vertical 5 minus 0. Horizontal 1 minus 0. And so the answer is 5. Okay, so Nora, yours is what do you think will be the SI unit of your slope? What will be the SI unit of the slope? Nora.
Meters per second square.
Okay, so meter per second squared. Yes, number 2. Number 2, what is your slope?
Sir, please, I had 5. 5 meters per
had.
second square.
Number 3. Number 3, what is your slope?
5.
5. Number 4.
Yeah.
Sir, please also at 5.
Good. So you see, along the straight line, you had the same value as the slope. So this kind of motion is uniform. Now, what does this slope actually mean? What does it mean? What does the slope of a velocity time graph mean? What does it mean? Yes, anybody?
The gradient.
Acceleration.
Gradient is, slope is also gradient, but what
Yes.
is the significance? Yes.
Slope of the velocity time graph is equal to the acceleration.
Thank you. So note that for a velocity time graph, for a velocity time graph, the slope is equal to the acceleration of the body. The acceleration of the body. So a very important thing you must note under velocity time graph. If you find the slope of a velocity time graph, it is equal to the acceleration of the body. 2, another observation under a velocity time graph is that the area under the graph, if we find the whole area under the straight line, this area, which looks like a triangle, if you calculate the area under a velocity time graph, it must also give you the total distance covered by the body. So the area I'm coming here. So the area under a V dash T. V dash T means velocity time. the area under a V-T graph is equal to the total distance or displacement of the body. So class, under a displacement and a velocity time graph, we are getting two features. The first one is that the slope of a velocity time graph is equal to the acceleration of the body, and the area under a velocity time graph is also equal to the total distance traveled. Please, are we okay?
Yes.
These things, please, you shouldn't forget it. Very, very important concepts under linear motion or kinematics. Nora, are you fine?
Yes, please.
Then later on, you see how we can apply this. I'm coming. I want to quickly take a screenshot of today's attendance. Under displacement time graph, we only saw that the slope, okay, the slope is equal to the velocity of the body. But for a velocity time graph, we are seeing two different things. The slope would give you the acceleration of the body, and the area under it would also give you the total distance traveled by the body. And this kind of graph, this graph is known as uniform accelerated motion. So this is a uniform accelerated motion. Okay, so I want somebody to help us understand what a uniform accelerated motion is. What is a uniform accelerated motion? Yes, what is a uniform accelerated motion? Anybody? Okay, Ken, if you are all not trying, I think Ken will be there for us. Ken, what is a uniform accelerated motion? Oh, Gerard's hand is up. Gerard, okay.
Sir, please, a uniform accelerated motion is the motion of a body whose rate of change of velocity with respect to time is constant.
Perfect. Another way to say the same thing. So Gerard is using rate of change of velocity with respect to time being constant. In what other way can you define a uniform accelerated motion? Yes. Anybody?
There's a type of motion with constant acceleration.
Yes, it is the same thing as it was said earlier. More views. A uniform accelerated motion is also a kind of motion in which the body moves with equal velocity within equal time interval. The body moves with equal velocity within equal time interval. So look at this one. Equal velocity, from 0, move to 5, 5, 10, 10, 5, 15, 20. You see, so at every increased time, the velocity is the same. So the body moves with equal velocity within equal time interval. And this is a uniform velocity motion. Another kind of motion. If we have V0, 6, 10, 12, 13, 20, 22, time 0, 1, 2, 3, 4, 5. What is happening? The time changes within equal intervals where the velocity is increasing, all right, but it's not uniform, right? The velocity is increasing, all right, but it's not uniform. So when you plot such graphs, the velocity against time, you have a curve. You have a curve. Okay. The curve, because it's a curve, you cannot determine velocity, uniform velocity for the whole graph. But you can only determine velocity, the slope within a given time. And when the graph is curvy, you can only find the instantaneous acceleration. Instantaneous acceleration. Maybe I want to determine the acceleration at a time 3 seconds. So what I do is that I connect this to 2, draw a right angle, a triangle to find this. Let's assume the change in this point is to a velocity of 2. We have a velocity of 4. So it means change in velocity against change in time. So that slope at time t is equal to 3, this will be equal 3 seconds. This will be equal to change in velocity, which is 4 minus 2 over change in time, which is 3 minus 1. So the slope here will be equal to 2 over 2, which is 1 meter per second squared. So this is the acceleration at a time t is equal to 3 seconds. So under a non-uniform accelerated motion, you can only determine the instantaneous what? You can only determine what? The instantaneous what? So on a non-uniform accelerated motion we can only calculate or determine the instantaneous acceleration. And what is instantaneous acceleration? Acceleration within a specific time. Are you okay?
Yes.
All right. Then if the graph is like this, it's a velocity time graph, but the graph is like this. What does it mean?
Hey.
Yes, it's also a velocity time graph. Velocity, we have a velocity time graph. And the graph is like this. What does it mean? Anybody? Charity Mensah. Charity, can you help us? The graph is like this. Okay, anybody else to help? Anybody else? Nora.
Yes, please.
Nora, welcome now, money. Try.
So I think when it's like this, it means the velocity is 0.
The velocity is 0. Velocity is 0. No, Nora is a velocity against time graph. So these values, V is 0 here, maybe 2, 4, 6, 8, and then maybe 10. Okay, more views. Nora has tried. What about you? Oh, Ken. Anefi, just try, okay? When you get it wrong, it's part of learning. Just give it a try. What's the meaning of this graph? Gerard.
Please, it means that acceleration is negative.
Acceleration is negative. Okay, thank you. So that's it. This is a uniform decelerated motion, because the value of the acceleration will be the same, but the only thing is that it is negative at all times. So this is a graph of a uniform
Deceleration.
decelerated motion. Decelerated motion, or a uniform retarded motion. Let's calculate. If we pick any 2 points and want to find the slope, let's pick these 2 points. So 6 and 2. So change in the vertical against change in the horizontal. So delta V against delta T. This slope is such that it will be equal to change in vertical over the change in the horizontal, which is time. What is the final vertical? The final vertical is 2. So 2 minus 6 divided by the final time. Let's assume this is 2, 3, this is 4. So 4 minus 2, 4 minus 2. 2 minus 4, 2 minus 6, 4. So minus 4 divided by 2, which is equal to negative 2 meter per second squared. So the slope of a velocity time graph is equal to the acceleration, meaning this acceleration is negative. So, and once acceleration is negative, it's a decelerated motion or a retardation. So the acceleration is negative. So this is also a uniform decelerated or retarded motion. Please, are we okay? Are we okay?
Yes, sir.
All right. Then the final probing is this. And I'm going to give this question to Lawrence. Today I've not heard from you and I'm not happy with it. Lawrence. Hey. Lawrence is here too. Calvin.
Yes, sir.
Lawrence, what's the meaning of this graph? What's the meaning of this graph?
So this is a stationary graph.
Stationary graph. Okay. View 1, view 2. More views. I have one view. Lawrence is saying this is a stationary graph. What do you have to say?
Please, please, which one? Is it the one up there?
The downward graph here. Let me open a new page and then draw. So VT. But the graph is such that it's like this. What is the meaning of this graph? Anybody?
The graph is stationary.
The motion is stationary. Okay, more views.
Acceleration is 0.
Acceleration is 0. So let me put down what you are saying. So let me put down a
Velocity
motion.
constant.
I'm coming. Motion is stationary. Acceleration is 0. More view.
The velocity is constant over time.
Velocity is constant. As constant over time. Is that all? Okay. So let me make my choice. Acceleration is 0. Motion is stationary. Is incorrect. Acceleration is 0 is correct. Velocity is constant is also correct. Why do you think motion is stationary is incorrect?
So stationary means that
it's not moving. But as per the graph, is it moving?
No, sir.
No, sir.
Per what we have on the graph, is the body moving?
No, sir.
Yes. The body
No,
is
sir.
moving. But it is only moving with the same velocity, constant velocity. And if the body is moving with a constant velocity, its acceleration is 0. So please, if you have a velocity time graph and the gradient or the slope is 0, it means acceleration is 0. Because the slope of a velocity time graph would give you the acceleration. So if the slope is 0, it means acceleration is 0. If acceleration is 0, then technically it means that the body is moving with constant speed or uniform speed. So it's similar to somebody running a long distance event, and when the whistle went, beep, he started with a particular speed and was able to maintain the same speed till the race ended. So when the person maintains the speed throughout the race, it means he's moving at a constant velocity where the acceleration is 0. Class, are we okay?
yes.
Andy and Co, are you okay? So what then is the difference between these two graphs? We have A, what we just spoke about, and B, this graph. B is a displacement time graph. And the graph is like this. Nora, what is the difference between A and B?
Okay. In A, the body is moving. It's just that acceleration, the body is maintaining the same velocity. But
Okay.
like in B, the body is not moving at all.
So the body is what? Stationary.
Yes.
Okay. So class, before you talk about a graph, you must identify whether it's a displacement time graph and velocity time graph. For a velocity time graph, this is the motion of a body whose velocity is constant or uniform. Velocity constant, constant or uniform. And then B is a graph of a stationary body or body at rest. Or body at rest. Are we okay? Are we okay?
Yes, sir.
Another question. What is the difference between these two graphs? This is displacement time graph. The graph is such that it is like this. The second graph is also a velocity time graph, but the graph is such that this is it's a velocity time graph. Graph is like this. What is the difference between these two graphs? Let me name them graph A and B. A graph A and then B. Anybody? What's the difference between these two graphs A and B? Anybody to share that with us? Yes.
The A is in uniform motion with constant velocity, but the B is showing that velocity remains constant over time.
So one word to describe the relationship between A and B. One word. Just a word to give me a relationship between A and B. Ken, are you there?
Yes, sir.
Gerard, you are all Lawrence, Kelvin, Charity, Emmanuel Jones, Andy. Yes, one word to just explain the relationship between the two. One word.
Proportionality.
They are what?
That means their velocity is constant.
Their velocity is constant. Nora, one word.
Proportionality.
Proportionality.
Equivalent.
Equivalent. A is the same as B, so they are the same. So one word, same. This is uniform or constant velocity. Okay. Uniform or constant velocity. This is also constant or uniform velocity throughout. So this is the same as this one. But this is not the same as this. So take note. Take note. All right. So the graphs of motion is very, very important. You must understand and use them. Else, when I'll be giving you trial works, and you see how this actually works out. Okay. Last one. I have this graph. It's like a puzzle. I have this graph. It's a velocity time graph. The graph is such that it moves then from here comes this side and then comes to this point. This is from 0. This is 0, 5. This is 10. This is 1. This is 2. Three. This is 4. Five, and finally 6. Our work is 1. Describe the motion of the body. The motion of the body. 2. Determine the acceleration. Determine the acceleration during the first 2 seconds. Then 3. That determine the total deceleration of the body. The total deceleration of the body. And lastly, the total distance traveled by the body. The total distance traveled by the body. Yes. Who would answer the first one? A volunteer to help us answer the first one. The first question asks that we describe the motion of the body. Help us describe the motion of the body. Who would volunteer to do that? Oh, raise up your hand so else I'll call you. Okay, Ken, your microphone is on. So over to you, Ken.
So the body accelerates uniformly from rest to a velocity of 5 meters second square. And the body moves with a constant velocity at 5 meters per second square. And The body decelerates uniformly to rest. The body remains at rest. Say,
Ken, I'm listening. Oh. Ken, I'm listening.
I said the body accelerates uniformly from rest to a velocity of 5 meters per second square.
It's
the body
what accelerate uniformly to rest or from rest?
from rest to
Okay.
a velocity of 5 meters per second square. And then the body moves with constant velocity at 5 meters per second square. And the body decelerates uniformly to rest.
Okay, so that is Ken's opinion. Please, do you have any different opinion to share with us? Do you have any different opinion before I come in? All right, so listen. The body moves with a uniform acceleration. Okay, the body accelerates uniformly to from rest. Please, from rest means that the initial velocity is 0. The body accelerates uniformly from rest to a velocity of 10 meters per second, not 5. 10, not 5. 10. You see,
yes, sir.
It started with an initial velocity 0, and then increased its velocity, accelerated, and got to a final velocity of 10. So it accelerates uniformly from rest to a velocity of 10 meters per second within a time interval of what? Within a time interval of what? What's the time within which this acceleration happens? 2 seconds.
2 seconds.
Okay. Then from there, maintain its velocity for further how many seconds? From there, it maintained its velocity for further how many seconds?
4 seconds.
No.
3.
Maintain
3 seconds.
3 seconds. So 3 plus 2 would be 5. So it maintained here, the velocity is not changed. So between 2 to 5 seconds, whose interval is 3, the velocity is maintained. Velocity maintained. So constant velocity. Please, I hope we are following.
Yes, sir.
Then it uniformly decelerated to rest. It's uniformly decelerated to rest. To rest means that the final velocity is when the straight line touches the time, it means the velocity is 0. And then it uniformly decelerates to rest within a time interval of what? Within a time interval of
1 second.
1 second. So it took 1 second for this uniform deceleration, where the velocity was reduced from 10 to 0. So part 1 is about uniform acceleration. Part 2 is about 0 acceleration, where the speed is maintained. And then part 3 is also uniform deceleration. Class, I hope you understand.
Yes, sir.
So that's it. Then the second question. Determine the acceleration during the first 2 seconds. This is the acceleration. The body uniformly accelerated during 0 to 1, 1 to 2. So during the first 2 seconds, this is what happened. The body uniformly accelerated. And I said that the slope of a velocity time graph would give you the acceleration. So help me find the slope in 1. Help me calculate the slope in the first part of motion.
Okay.
Please, it be 5 meters per second. 5 meters per second squared.
Yes, sir. 5 meters.
Okay. Please, Charity and the rest of you, are you following?
Yes, sir.
Yes,
So
sir.
when you calculate slope, change in vertical over the change in the time. So 10 minus 0 divided by 2 minus 0. So this is 5 meter per second squared. Okay, so it means that the acceleration is 5 meter per second squared. All right, the third question. What is the total deceleration of the body? Yes, calculate that for me. So this is 2, 3. What's the total deceleration of the body? The deceleration in the body is just the third part of the graph. Is the third part of the graph. So when you find the slope, you have the total deceleration.
Sir, please, negative 10 meters per second.
So when you calculate, you have change in the vertical, change in the horizontal. So the acceleration, okay, I'm coming. The acceleration in 3 would be, the final is 0, the initial is 10. So 0 minus 10 divided by 6 minus 1, 6 minus 5. So this is minus 10 divided by 1. So the acceleration is negative 10 meter per second squared. The acceleration is negative 10. So the total deceleration is 10 meter per second squared. Please listen. I'm saying that the acceleration is negative 10 meter per second, but the total deceleration is 10. If I talk about deceleration, I don't bring the negative because every physics person knows that deceleration or retardation is negative. So when I talk about deceleration, I'll bring the numerical value and wouldn't bring negative. However, if I talk of acceleration, I'll bring the negative. Are you okay? The total distance traveled by the body, yes. How do we determine the total distance traveled by the body? Are you trying?
Yes.
Okay. don't forget, under this concept, we've learned that if you have a velocity time graph, the area under the graph would give you the total distance traveled or the total displacement. Later, we'll distinguish between how to calculate displacement and distance. Okay, let me create a scenario to address the two, then we move on. The same question, but I'm going to modify it a little bit.
It's fine.
You had what?
It's fine.
Okay. I want to extend the motion a little bit to also cater for. In this case, I extend the graph downwards. So this area is the area of a trapezium. So if I want to find the total distance traveled, I first determine the area of the trapezium above. So the total shape above under the graph, the whole motion. You see this area, and then okay, let me also, this 6. Let me assume that this is there's 7 here. This is 7. So the total distance would actually be the whole area under the graph. The upper part is the area of a trapezium. And what's the area of a trapezium? How do we determine, formula for determining area of a trapezium? Quick one. Revision. Formula for finding area of a trapezium. Have A plus B times the vertical height, isn't it?
Yes, sir.
You've forgotten. The rest are quiet. What is A? A is this part, the shortest part. B is from this point to this point. And H is the perpendicular height to both sides A and B. Looking at the graph, what will be A? What will be this distance? Class, what will be the magnitude of this distance? This is 5, this is 2. So what's the interval? 3, isn't it?
Yes.
Then this is 6. B starts from 0 to 6. So plus 6. What is this height H? What is the value of H? 10. So we have, this is 5. When you sum up 6 and 3, you have 9. 9 times 5 is 45. So the upper part of the area would give you a distance of 45 meters. Then the downward part, you see the small triangle is also an area under the graph. So you find the area of the triangle. So this area is a triangle, so have base times height. The base is this, from 6 to 7, so 1. What is the height? The height, I said, let this be 1. So 1. So this is half. Please, are we following?
Yes.
Okay, so the total distance will be equal to the area under the whole thing. So 45 plus 0.5, half. So this is 45.5 meters. That will be the total distance traveled by the body. What's the total displacement? You see, if this had not come, if this part had not come, and then we only had the upper part, the total distance would have been equal to the total displacement. But because we have this, we have one part of the movement along the positive, this is like positive y-axis, and what is happening here is along the negative. So the upper part is positive, the downward part is negative. So we have 45 plus negative 0.5. So when we subtract 0.5 from 45, we had 44.5 meter, isn't it? Class, isn't it?
Yes, please.
So this is the total displacement. So total displacement will be equal to, so for displacement, we are interested in direction of movement. So we look at the upward total distance, which is positive, and then the downward total distance, which is negative. And then we subtract the negative from the positive. That will give us the total displacement. Okay, so the total displacement is 44.5, whereas the total distance, we don't care about direction. We are only interested in the whole coverage, and that will be 45 meters. Any question here? Class, any question?
Yes, sir.
So this is it about velocity time graph. We've done displacement time graph. We've done velocity time graph as well. Okay. The next thing we have to look at, which we would actually expand so much next week, will be equations of motion. Equations of motion. We represented motion on a graph. We are going to look at mathematical equations which will help us determine distance, displacement, acceleration, and all that. And when you understand these two, it is always fun working with them. So equations of motion, we consider a body. Considering a body, starting, so considering a moving body,
Initial velocity.
with initial velocity u. The body is moving with an initial velocity
Final velocity.
u, and the final velocity v. V, having covered a distance, s in a time interval t. So for equations of motion, we consider uniform accelerated motion. Okay, we consider uniform accelerated motion where the body moves, where the rate of change of velocity with respect to time is constant. So if a body is moving from one point to another and the body's initial velocity is u, final velocity v, and then the distance when the body accelerates, it covers a distance s within a time interval t. If I want you to help me calculate the acceleration, how do we determine the acceleration of such a body? Nora, under this circumstance, how do we calculate the acceleration of such a body? The body's initial velocity is u, final velocity is v, and the time interval, the time taken to accelerate is t. How do we calculate the acceleration of the body?
So I think the acceleration will be v minus u over t.
Exactly. So acceleration is change in velocity over time taken. So the change in velocity is the final velocity v minus, so let me write it in words to help your Form 1 student. So final velocity minus initial velocity divided by the time taken. So in letters, final velocity is v, initial velocity is u. So v minus u divided by t. From this, help me make v the subject. Help me make v the subject. V will be equal to
negative u out of t.
check, make v the subject. You first cross multiply, isn't it? So you have a times t. So if I cross multiply, I have a times t is equal to v minus u. How do I make v the subject? You make v the subject by sending u to the other side. U is negative. When it crosses, it will be positive, isn't it? Isn't it? Oh, respond. Isn't it the case?
Yes. Yes.
Yes.
So when you make v the subject, it will be equal to u plus at. This, ladies and gentlemen, is the first equation of motion. First equation of motion. First equation of motion. Where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. So next week, we'll look at the second and then the third. And there's a sub one we often call as a fourth. But the main equation, they are actually three. Okay. So we'll derive equation. We've done for equation 1. We do it for 2 and then 3. Then combine the graphs and then this one in solving problems. And you realize that, oh, it's a powerful tool you have actually had. Is there any question? Is there any question?
Can the distance also be displacement?
Yes, well, in the the second and the third equation, there will be displacement as well. This equation is about the velocities, it's about acceleration. And don't forget, acceleration is about changing velocity with respect to time. So once equation 1 is about acceleration, that is why we have only initial and final velocity and then the time interval. Okay. So in equation 2 and 3, you see the distance covered or the displacement within it. So on this note, this is where I end today's session. Okay, a lot of you are even running. We were about 14. We are left with only 9 here, including myself. So we'll continue on Monday next week. Okay.
Okay.
But I'll send you some work sets just to help you apply whatever we've done under graphs of motion. Okay. Now I also send a video, yesterday's and today's as well. Please, when you happen to watch it and then you go to the site, please subscribe to my channel and then be doing the sharing among your friends for me. Okay.
Okay, sir.
All right. Bye-bye to you all. See you. See you again. Your
Bye-bye.
assignment will come.
Okay, sir.
Bye.
Okay.
Bye-bye.
Bye. Bye.